we are back. We will hear prompts to production, building effective security automation for everyone. So please welcome and give it up for Jozsef Ottucsak.
All right, so thanks for having me first. Prompts to production, building effective security automation. This is the title. There will be some slight changes, but first let me introduce myself. So this is me. I've been in software, cyber security in the last 12 years, 13 next month. I've worked at cool startups, scale-ups globally, like LogMeIn, LastPass. Right now I'm at Diligent. So I love AI, the technology that includes like machine learning and like basically all areas, not just generative AI. I love it so much that during COVID I did data analytics and machine learning master's degree because I was bored. And I also love cybersecurity, so I love getting the two together and merging and seeing what we can do when we mix those two. So if you are a security practitioner, you have probably heard about the Mythos preview, the Anthropic Red Team, how it's so good that Chinese are using it to hack like Western companies. And you can see that this kind of influences how the market share or market price for cybersecurity companies are valued at the moment. So if you listen to the industry, the hype people, they say that cybersecurity is dead and agentic security is the best thing since sliced bread. So what we're seeing is like a paradigm shift that kind of tries to tell us that there is a new way of working, and if you see through the glasses that we currently wear, this is true because AI is generating massive amount of work for everyone involved. So you kind of have to keep up with that velocity if you are in security. So by introducing AI models and agentic workflows into the picture, you're getting a lot of work coming in, and you have to address that somehow. So the security teams basically need to scale. So the goal of this talk is two things: to basically expose you to how you can use agentic workflows, AI generally for your work or for personal goals as well. And because this would be kind of boring if I just did that, because everyone publishes talk about how to scale up security using AI. And I'm going to give some personal information about how I set up my own home lab and how I use AI generally in my work and my personal life. So to kick things off, we are going to go with some primer on AI tooling, processes, history to just understand what's going on behind the scenes. We're going to talk about happy paths, problems, and tips and tricks that I saw during my AI use, and just some exposure on how I use AI at my work and on my personal projects. So first thing first. So generative AI is about generating stuff. Like it's basically behind the scenes predicting text using mathematical patterns learned from vast amounts of data. So you train the model, it kind of establishes an internal abstraction of the world as how it sees it. You feed it some prompts, and then it's going to generate some output that is likely to be the output based on weights and probabilities that has learned from before. So, long story short, it's a fancy text generation like application. So that was how it all started. Then bright people decided that if you generate like an intermediate layer of thinking, like breaking down tasks into smaller steps, and teaching the model to act similarly, then you can get better results. So this is the reasoning. And reasoning is often blocked from the user. So whenever this kind of happened, that was already a shady move from the model providers, because by generating reasoning tokens, you are doubling, tripling, quadrupling the price, because the model is generating output and it's usually hidden. So those are tokens that are generated, but you're not paying for it. So the user can only see that, okay, the thinking model works faster, well, not faster, but better, but they don't see the costs that kind of happen behind the scene. So these were the first two things that kind of revolutionized how AI works. And then we move on to tool use and resource something generation. I don't remember now. So far, the models weren't able to reach out to the outside world. They couldn't interact with the world, so we basically had to invent some kind of methodology for the runtime to execute certain things based on what the model generated, and that allowed the model to act. Then we have things like multimodal models, which allowed the model to see images, basically transport them into vectors that it can understand. The same thing for audio, video, you name it. So what this allows for a model to act based on what it sees, what it hears, text-to-speech, whatever. So we are not restricted to text right now only, but other means of communication. So after that, and now we are currently arriving where we are now, we have computer use. So computer use allows the agent or the model to interact with the desktop. Like previously, you could use the chat interface, which is, I don't know, not sure how you like it, I don't. I like the command line interface, so that works for me, but not for the average user who want to kind of use like a desktop app. So that way, someone who is a non-technical person can use an agent to do some of the work for them by interacting with their desktop, like troubleshooting their Wi-Fi or using their browser to, I don't know, interact with a database that wasn't exposed previously. So this kind of allows to automate some of the workflows that weren't possible because maybe there wasn't an API to interact with before, or maybe you just couldn't use it. Maybe you need to log into different machines and extract data from there. So this computer use kind of allows some of the legacy systems to be put together in order to automate some of the work that you weren't able to do it before. And the last step where we are currently so far is the enterprise AI workflows. So this is not a new thing. This is like those no-code solutions where you click together a workflow and it executes some of the stuff. But so one crucial difference between that and this is that it's kind of fault tolerant. So when you orchestrate it with an agent, then it can prepare for failures, and you are able to make sure that the execution still works if something don't look right. Maybe the output is not what you've expected. And previously, with like stricter, more defined automation, this kind of break the entire pipeline. But now, an agent can do small error correction like autonomously. And how we can deploy this? Well, we have local. When you host the model, host everything at home, you have infrastructure as service and APIs. So all of the frontier AI labs offer APIs, and all of the cloud providers also offer some of these models through API. You can rent GPUs and deploy your own open weight models if you want through infrastructure as service or platform as service. And you can also host these locally. So why you would host this locally is data control. Like if you control the data, if you control the inference, then that data doesn't go out anywhere that you don't want to. So this is pretty much depends on your use case, your risk tolerance, whether the data needs to be tied to your geographical region, but arguably if you want your data to be in trusted hands, then you can host your own. The resource efficiency right now is very shady when it comes to the market economics of this whole thing. So local is very expensive because you're not subsidized by VCs. So you have to pay market prices for GPUs, unlike like other large companies. And that kind of makes it expensive. Plus, you don't have the economies of scale like you have it with infrastructure as service or API. So you always end up being better by using an API because it's financed by VCs. So if you want the bubble to pop faster, then use those services which are kind of subsidized. So the free services, the coding plans. I will have a really cool image about how it's complete madness, how these model providers act. So hosting your own kind of means that you have to manage it and maintain it. So just before I arrived here, I looked at Twitter and saw that there is a light LLM SQL injection vulnerability. And I have a large language model proxy at home because I will tell about it later, but I basically had to patch it because there was a SQL injection vulnerability. So if you kind of put these and host on your own, then you're going to have to face some headaches around fixing these things because, bit rot, maintenance, security, this is not a thing that you deploy and just leave it. Otherwise, it's going to be like an insecure mess. The other thing is that when you're using infrastructure as service or local inference, then you are basically stuck with open weight models because that's the only ones you can use. Like you can't access, for example, Anthropic's stuff, just what's available and on Hugging Face, for example. So here is my local setup that I kind of did. Everything is repurposed. This didn't start up as like an AI kind of thing. So I have an agent runner, which is a refurbished HP workstation. It was cheap, super cheap. Like these refurbished ex-business machines are stupid cheap for what they do. I replaced the GPU with basically the latest model that the PSU can steal power and replace the RAM within it. So this is much more powerful than Raspberry Pi, but consumes more resources, and I couldn't really justify a Mac Mini for this setup, but otherwise I would have gotten this. So how I do things with it, there is a traffic reverse proxy offering authentication, authorization, HTTPS, so that I can use HTTPS even on my local network. I have Claude coding agents running through client Kanban. I will show a picture of it later. I have a light LLM proxy, which uses one token connecting to my cloud provider, like my inference provider, and multiple virtual keys. And what it basically does is I have often dozens of coding agents who kind of do things autonomously. And if I would use just a single API key or multiple API key, I would face rate limiting issues. But now the LLM proxy basically handles this for me, so I don't get timeout problems or rate limiting errors, and I can just launch it however I want. Then I have an open web UI that I don't really use, but I deployed because why not? And I have an open CLO just to manage some of my stuff. So that's pretty closed down. Like I only connect it to my messaging service, so there's no attack surface there. That I made sure of that. So the next steps for me with this setup will be evaluating Pi, the coding agent, because that's like much smaller, pollutes the context less than other solutions, and looking at Hermes agent. And I also have a local AI inference machine that used to be a gaming PC, but this is more for experimentation. Like I don't, it's too slow to be usable, but I can load models and kind of experiment with them. So this is like a great learning experience for me to basically deploy this infrastructure at home. So this is how it looks like. This is how I add tasks to my coding agents. Instead of like chatting with the application, I define tasks. I can set up like dependencies between them. So when one task is completed, it moves on to the next one. So that's kind of how I do it. And I also use some paid services, like Notebook LM is really great for like understanding documents. And the good thing about it is it's free so far. So I'm going to take advantages while that happens. I don't upload my own documents, that's for local, but for, I don't know, manuals, documentation, whatever, it's really great for that and it's free. So GitHub Copilot had a pretty decent free tier that was eliminated or severely cut down. Claude Code also had a pretty good free tier with 1,000 requests per day. Now it's only 100 requests per day. I use Google Gemini Pro for any of the usual chats or brainstorming or that type of work because for conversations it's good. For work-related stuff, I tend to use Bedrock with anthropic models because, yeah, why not? So, and for my personal stuff, I use Z.AI's legacy GLM coding plan Pro, which has also been eliminated. I can still use it until next year. Let's see about that. But if you look at my token consumption, that's like 6 billion tokens and 4,800,000,000 tokens purged in the last 30 days. So if you translate that to anthropic dollars, that's like $40,000 worth of tokens burned through API calls. If you translate it to GLM's coding plan, then that's around $6,000 worth of token consumption. And I paid $11 for it. So you can see that the economy doesn't really work out here. And whenever I need to basically fine-tune models, I just rent the GPUs through Rampod. They have like a really cool interface, and certain things are already set up there, so I don't need to work with building the Docker containers from scratch. So how I use chat. Chat is like the basic building block. It's a good fallback to everything where you don't really know what you want to do. But like chat is still something that's worth exploring. So if you're brainstorming or trying to find something in a code base, then chat is basically a good place to be because you don't define like a huge question up front. You just start exploring the code base like one by one. Maybe you want to research something. You don't really need to invest too much time if you use chat up front because you could just like explore things, and once you have everything formalized, then you can convert it to like an agentic flow or something. So how I use chat in my daily workflow is I dive into implementation specifics. I work for a company that has plenty of projects, so I need to be right on top of like recognizing a certain pattern or going in and finding the fastest way to uncover vulnerabilities or coding best practices. And we are talking about large code bases here, so I kind of need to jump in and guide the model to uncovering these things, or help the model help me uncover these things. And it's really stupid. So it doesn't really work the way you would expect it to work, that you go into the code, chat with it, and it prints out these critical findings. Because if you use it, then you will find that everything is critical. So everything is high, critical, and there is no mediums or lows. So you kind of have to think your way through again when it comes to these findings. So that's why I asked questions like, okay, but does it exist in production, or is it just a dev script that is running during the builds where it doesn't really interact with the outside world? So you have to explore those things, and the models will help you find these things. So what it's also really good at is like creating these one-liners, these quick shell scripts that, for example, delete certain files or converts certain formats into other formats. I'm lucky that we also have it integrated with most of our company data sources, the AI host that we use, so I can look for Jira tickets, Confluence pages, whatever, and then again, you have to find the right answer. It gives you options, but you still have to find the right answers. So the next evolutionary step after chatting was documented prompts, which were basically like chat inputs put down into one single files. So this is for standardizing some of the workflows that you have within the company, for example, or not needing to remember these things because you have it somewhere saved. These can be version controlled, and you can call it basically anywhere, or you can just save it into your notebook, copy, paste, and execute them again. So what we have right now with documented prompts, we have documented third-party reviews, like what it needs to execute during a third-party review. Rule generation is something that it can be useful, for example, for open group rule generation is something that I use this for. You can standardize an incident response format, like in your documented prompt that, okay, I always want it to look like this. So you can put this into a prompt and be happy about it. So I don't use them. The reason is pretty simple. I migrated everything to agent skills. So agent skills is a couple-month-old new advancement. We are still talking about text files here, so nothing advancement is really here. It's just another format that you have to work with differently. And when I need to do something that is like a repeated task, I tend to create a skill for it if it's like ambiguous about what's going on there, like how it may go into different direction, it's loosely defined. When something is really simple, like kicking a service or updating a service and just like, always updating a service, I write a script, I create a just command. So just is really cool for like all of those tasks that you want to invoke like stupid easily. And whenever something needs some level of persistence, I create a container or a quadlet, which is like a container that runs as a service. So the next level of evolution is hooks. So hooks hook into your agentic CLI experience. So let's say that you are editing a file and you don't want that file to be edited, then you create a hook that prevents that from happening. Like if you don't want the agent to read out secrets, then you create a hook that prevents that. So these communicate via JSON or exit codes, and you can automate tasks that would otherwise consume like a lot of context from the agent or the memory of the discussion. So I use it to automatically trigger certain things, but what you can do is load up like environment variables, run code, verify signatures, verify the validity of something. So it's kind of how I use it is I put deterministic checks within the agentic process. So I use a lot of hooks in my development and operations projects. It kind of makes it harder for the coding agent to turn everything into an unmaintainable slop. So that means I'm running like a formatter, a linter, security scans, SCA. So everything that you would kind of do in like an enterprise software development environment. But with AI agents, it's so much cheaper to generate them. So even for your like crappy hobby project, you can write automated tests, negative tests. You can ensure that the firewall rules are correctly defined and like tested statically and dynamically, rebuild knowledge maps. So it's a pretty cool way to work, and you don't need to pollute your agent MD file with all of this unreliable way of defining workflows, because you just say that when I'm modifying this Python file, always execute static analysis on that. So I love it. Then we have the skills. So skills are the standardized ways of sharing capabilities. So you can pack up like prompts, resources, assets, whatever you want. And the only thing that's required is like a special formatted skill file. And then the agentic IDE or CLI or whatever you are using can include this and basically use it as a resource. And I only use a couple of carefully vetted skills because it's horrible what's going out there. I use superpowers optimized. So this is like a smaller version of the common superpowers skill that is bundled with Claude Code. So it allows like it has like certain predefined workflows about brainstorming, test-driven development, troubleshooting, bug fixing, using subagents, whatnot. So I use it for that. I use Grapify. Grapify kind of builds a graph representation of all the documentation and all of the code that you have. So this makes it much cheaper for an agent to retrieve information without burning so many tokens. Same with RTK. This simplifies and groups information where the output of the tools are too verbose. So the problem with some of these things is that most of the skills that people have written is AI generated and slop. Like they focus on the wrong things. They just ask the AI to generate something that looks good, but doesn't really help with the actual problems that the AI has. So you have to really look at the workflow that you're doing and just fine tune it. So these are like natural language instructions. So if you can be bothered to write that, then you probably should not execute AI workflows. But then again, focus on the things that matter. I would just recommend building your own, or just when you download a skill from the internet, always glance it through and delete the lines that you don't need. And so one of the coolest things that has happened to AI is the subagents. So if you're not familiar with subagents or how agents work in general, so the previously agents had like a shared context, and you try to do everything with an agent, and like the agent has this amount of memory, and you try to put in so many things, then first the agent's going to work less accurately and worse. But then again, if you reach the context size, then it will crash. It will simply not work anymore. So subagents can be used so that you can offload some of that cognitive functionality to other agents. That means like you have an orchestrator agent with this much context. You have it calling a subagent doing some task that, for example, would almost deplete the entire context. Then instead of like putting everything back into the orchestrator agent, it simply returns with the output that you need, which might be like a single yes or no answer. So you can basically delegate a lot of the work and work with larger code bases, do more complex tasks, and as Some of the frontier labs also charge based on context use. So if you use too long discussions or too long agentic loops, then you're going to end up paying more. So I use subagents for everything because it kind of allows me to work on a better way. And here is like one way that I kind of wanted to show you guys, a personal project of mine. So I'm really into synthesizers and effects, and unfortunately they take up too much space. So I have too many synthesizers that I want to get, but I don't have enough space for them. And like the one cool thing about them is music technology. So I'm much more interested in how they work and not how they sound. So I decided that maybe I could reverse engineer ARM binaries to find out the DSP and kind of understand how the signal works and what kind of algorithms they used. So this was like a small project of mine. I created like a plan. There are subagents that download the firmware, reverse engineer using CLI tools like Python code, for example. It generates Python code, it uses XXD, and just basic reverse engineering applications. So don't even think like G-Hydra or anything like that. So it extracts the signal flow, what kind of algorithms they used, what were the magic parameters like filter coefficients and parameter ranges, whether the parameter controls are linear, exponential, or any kind of like different mumbo jumbo that they use there. And it documents it into a file that I can read. It also generates a super collider code and JavaScript and HTML. And agents are lazy, so you basically have to verify that the implementation is accurate and truly fixes some of the inaccuracies that are in the code. And you have to repeat it 2 or 3 times to get to the point where it doesn't really find any more inaccuracies. So that's like a good confidence for me. This is one thing that I did. So clouds, I reverse engineered an open source firmware just to understand whether this works. It used like, so how you updated it to your synthesizer is there was a WAV file, like an audio file, and I had to basically turn that into an ARM firmware binary. Another project that I did for fun is I reverse engineered a drum machine, a digital drum machine, and turned it into a client-side only web page. So that's it looks like this. Sounds pretty cool. And if you automate even further, you have like agentic frameworks where you can interact using like a framework, like a visual framework, like drag and drop, graphs, or define them in code. So this is pretty useful if you have like a well-structured workflow that you always want to execute the same way, or you want to like formalize it because you are calling it 1,000 times a day. So this is good for that. You can do the same rule generation, just for example, based on tickets that are in your Jira backlog. So for example, let's say that you find a high severity vulnerability and then you want to turn it into a SEST rule that you validate on the fly. So if you allow developers to call the security review on their own third-party components and basically have like a human in the loop that finally approves, but everything before that is done by agents, then that is also an example of what can be cool to do with agents. And one of the first projects that we did with AI was generating system risk and impact assessment for the ISO standard. So these are all like cool use cases that are something that you can create on your own. And I basically wanted to show this is the SamGraph mobile security rule set. So I was super frustrated that there aren't any good mobile security rule sets. So I decided to create my own just to see if it's possible. And I basically parsed like Apple's and Google's best practices when it comes to security, the OWASP information available on mobile security, and turn them into rules that you can execute on your code base using Open Graph or SemGraph. The other thing that I did is it's kind of frustrating to oversee what you have deployed on your machine. So this is the agent runners security dashboard that I did. So yeah, it kind of gives me an overview on the deployed services, deployed packages, resource consumption, and will allow me to kick off some new services, investigate their health. I'm going to use it to deploy configuration methods to ensure that I don't get hacked by supply chain attacks, because I will be like checking every package before I deploy them as an update. So the agentic automation, one thing that you should take home as lessons learned is that you can fix a lot of problems using AI automation, but you can just as easily create 10,000 more with it. So I would recommend you to use deterministic tools and only use like agents and AI when you truly need to, because agents cost a lot of money. Right now, this might not be so much money, but once they start raising prices, it's going to be stupid expensive. And I've seen a lot of people just generating code and features just because they can. So the first question is you have to ask yourself is, should I do this? Because you're wasting time on automating something that might not be needed. And if you're automating something, try to make it so that it's asynchronous, uses batch inference and prompt caching. So if you use batch inference, that's already a 50% discount to your inference cost. So if you can make something go into a queue, then only just use the batch inference when it's needed, then you're going to end up saving a lot of money. And what's cheap to do with agents is writing code, tests, automation, and making decisions. So don't try to boil everything and do everything with agents, because it's going to be like crazy expensive. You can put an agent into like certain choke points and decide, okay, that based on this input, I recommend running static analysis. I recommend dynamic analysis. But even then, like think about whether that can be a deterministic check instead of like an agent deciding that something should be done or not. So if you have a business critical problem that you cannot scale because you don't have enough humans available, then you can use it. Just because it's expensive, it doesn't mean that it should not be done. Like if there is a return on investment, then yeah, do it. But it's crazy expensive for anything done at scale. So it's a linear pricing. The more data you put in, the more expensive it's going to be. The more times you call it, the more expensive it's going to be. So that kind of becomes a problem when you're like sending 1 terabyte or 5 terabytes of data. That's going to be like a $30,000 monthly expense for you. So try to use like small models that were created for a specific purpose instead of using anthropic models everywhere, and try to avoid like ambiguous or flaky tests that require an agent to try again over and over and over again. So we are using a certain STA provider who has like really flaky checks. So maybe they are not the right provider or tool to integrate into an agentic loop that would end up failing like a lot of times and maybe goes down for 3 hours a day. And just as a final touch, some of the projects that I did using AI is I wanted to convert my synthesizer patches from one format to another because like there are different formats for the same thing. So I did a web page that does this. And I also did like a video synthesizer that kind of executes shaders. You can rearrange shaders, set up modulations, that type of stuff. So yeah, I just wanted to introduce some cool concepts that can be done using AI. And if there are any questions, then I would take them. If you don't want to ask, then you can find me after the talk as well.
Absolutely. Okay, thank you so much, Jozsef.